So let's find, we can remove this. Sorry. Oh yeah. Okay. So we need to find our relative extrema. So that will be the next thing to do. Let's bring this down. So find relative extrema. Local minima and local maxima. Now how do we go about this? So we first find our maximum index. Let's call it max index. So this, so the index is where we have the maxima. Is being represented by this. So let our max index be algorithm extrema price dot values. We pass price the value because we don't need any date for this function. So we are just going to be working with the data. So that is why we are passing the price dot value. Yes, the numpy dot data should be here. Here the comparator numpy dot greater. Here decide whether or not the point it is looking at is bigger than the other point around it. Then we have the other. So let's put it to be 1 for now. The other here is to smoothen out the noise, as we shall later find out during the course of the program. So we use the other to smoothen out noise. We have 0. This is being added so that we don't have a tuple format. So for our main index, make it more clean. Next, okay. Next tree. Price the values. The values numpy dot less. Similarly, the numpy dot less here decide whether or not the point it is looking at is less than the point around it. So we have the other smoothing out noise. So let's print out our maximum index and minimum index, and let's see how it looks like. Print. Max index. Index. Yeah. So let's save. Control S. Run this. Good. So let's check. Let's check out. So the first over here to here is for the maximum indexes. The second, good. So let's go back to our code. We need this element. Let's remove. Now, to add these indexes together, you have to add them together by converting the array into a list, because you can add lists together so that they won't add on top of each other. And this can be achieved by adding lists at the back of our Algorithmic streamer here. So let's add list here. Yes, something here. Right. Yeah. So let's add now. So we have the IDX. So we are adding the total indexes together. Let's add the maximum index and the minimum index together. Then we need to sort them so that they can be in ascending order. Let's sort them. So IDX sort. Yeah. And let's find the peak. So the peaks for the price, the value, the value, the IDX index. So we can plot this now. Let's plot and see how it looks like. Plot LT, the plot, is the values. So we plot this to see the values. MPLT, scatter. So now our scatter we put IDX X C. Let the color be green. So here, so let's plot SPLT dot to save it. Yes, save it. Save it here. Dot the PNG. Yes. So here I'm generating a plot and saving it as image file named plot.png using the save fig function from matplot library. So let's go up to import our matplot library. Import matplot library. Also matplot library dot use GG. So the HG, it is an abbreviation for anti-grain geometry, which is a high quality 2D graphic library used by Matplotlib as a rendering engine. So the plot will be saved without relying on a graphical display. So let's check here now. Are we in order? Let's check. So that's right. Let's save. Control S. We run this and let's see how it looks like. Python. In.py. .py. So all right. So here is our plot.png. So let's open this. Good. All right. The noise, there's too much noise there. So from the plot, in order to smoothen the noise, so let's go back to our code here. Then you adjust the order here. So let's adjust this. We increase it to 5. And let's see how it looks like. 5. Let's see. Control S. So I need to remove this. Then the noise is too much here. Let's remove this and run again. So let's see. So now let's try again. Good, let's check this. So completed. So let's check this. Yeah, look much better. So now since we've gotten the peaks, let's go and get the pattern. Well, assume that this is today's. Let's assume that this is today's peak. Now we have the maximum. So this is the maximum. But we have no idea in the future whether the price will go beyond it, forming new maximum or not. We need to make sure we are not looking at the future at all when deciding our point, but our grand extrema does look into the future. So how can we avoid that? We can avoid that by only giving our grand extrema data up to a certain point by iterating through and use the iterators as to this current value and should be able to eliminate the problem. So let's go and do this. So let's close this. So back